let's take the next chapter, and this is chapter 2, where we are taking portfolio analysis. Portfolio analysis, we know that a portfolio means investment in different assets, investing in variety of assets. In this lesson, I will focus on calculations, and I will take 4 examples here, but I'll take 2, then 3 I leave for you as an assignment, even though the solutions you are able to see. Now this question starts from here, but I'll leave this one as an assignment for you. You go through this first question. It starts from here. Tom has bought shares whose percentage returns under various states of nature are given below. It goes all the way to this point here. So you take this one as go through this one, try to understand the solution. I'll take you through example 2, which starts from here. So we start from here. My name is Mr. Williams of Fatima Institute Center for CIFA Studies. We are based in Thika Town. In case you need our help, my numbers are just here, 0727871093. As well, a publisher and an author. We've written a variety of books. Therefore, if you need books for financial management accounts, that is CPA and CIFA, you can still get me through that number down there. Subscribe to our YouTube channel so that you may get updates as and when we upload classes. Let's take the example. So we are taking this illustration here. The following information relates to 2 securities in the stock market. The state of economy, boom, recession, recovery. Probability, 0.3, 0.2, 0.5. Return of security X, 10%, 12%, 15%. Return of security Y, 15%, 21%, and 25%. Required expected return of securities X and Y. Number 2, co-variance between securities X and Y. Number 3, standard deviation of securities X and Y. Number 4, Robert Mugambe has invested that percent in portfolio X and 70% in portfolio Y. What is the portfolio risk with respect to his investment? And number 5, compute the expected portfolio return. So that is a question. We start with question Roman number 1, which requires you to calculate the expected return of these securities. So simply, to calculate the expected return for each security, we have security X and security Y. You will be taking the probability at each state of nature. You multiply by the expected return plus the probability for the next state of nature times the expected return of that particular security plus the probability for the next state of nature times the expected return, and then you sum up. So the summation of that, to get expected return on security X, you get 0.3 times 10 plus 0.2 times 12 plus 0.5 times 15. Summation of that gives you 12.9%. So this is what I'm saying. Expected return on security X, 0.3 times 10 plus 0.2 times 12 plus 0.5 times 15, you get 12.9%. Then expected return on security Y, you take 0.3 times 15 plus 0.2 times 21 plus 0.5 times 25, you get 21.2%. Your answer now will be this way: 0.3 times 15 plus 0.2 times 21 plus 0.5 times 25 gives us 21.2%. So that was question number 1, that is expected return of securities X and Y. Next is covariance between securities X and Y. Covariance between securities X and Y. So what you do is that you check here what we are doing here. What you do is that you look at the 3 states of the economy, the boom. So you pick the return of the security, that specific security. For example, for security X, the expected return is 10. Then 10, you minus 10, you minus, what I mean by 10 is this 10 here. So I'm trying to explain how we calculate the covariance. Covariance, you'll be taking covariance 10 minus the expected return on security X, which you have calculated. So 10 minus 12.9. 10 minus 12.9. This is what you can see here. 10 minus 12.9 into brackets 15 minus 21.2. 15. Now the return now for security Y. 15 times, that is 15 minus the expected return which you have calculated, which means 15 minus 21.2, then you multiply by the probability, which is 0.3. That is at the boom. You work out that first, and what you get is 5.394. So that was for the boom. Then for recession, you take 12 minus 12.9. That is this one here. 12 for recession, return of security X. 12 minus 12.9. The 12.9 which you have calculated here. Then close the brackets. Then you take 21 for Y. 21 for Y, return for Y. 21 minus 21.2 times the probability at recession, 0.2. And then what you get, if you work out that, is 0.036. Then the next state of the economy is recovery. So you take 15 minus 12.9 into brackets 25 minus 12.2 times 0.5. Then finally you get your answers there. I believe you have understood what we are doing there. So covariance, to get the covariance, you look at each state of the economy. There are 3 states of the economy: boom, recession, and recovery. You go to boom, you take the return of the security that you find it at the table, then you minus the expected return of that particular security, which you have calculated, 12.9. So we're saying 10 minus 12.9, this one here, this is for security X, into brackets. 15 is the return of the security in the stock market that you find in the table from the question. Then you minus the expected return that you have calculated here, multiply by the probability, and then the rest you do the same in each state of nature. Then you sum up these numbers, you get covariance between securities X and security Y. And the covariance is 9.46. So we have answered number 2, covariance between securities X and Y. Next is standard deviation of securities X and Y. To get the standard deviation for each security independently, you will be taking the returns for each security from the question. I would start by calculating the standard deviation of security X. You take 10 minus the expected return, which you have calculated. We got 12.9. We got 12.9, or expected return on that security. So you'll be picking 10 minus 12.9 squared, you close the brackets, squared, times 0.3. Then 12 minus 12.9, close the brackets, squared, times 0.2. And then 15 minus 12.9, close the brackets, squared, times 0.5. So this is what I'm saying to get the standard deviation of security X. This is what we are doing here. And then you sum up this, you get 4.89. Standard deviation is the square root of that, and we get 2.2111. That's the standard deviation for security X. Standard deviation usually measures the risk. The same will apply to security Y. Now we want to calculate the standard deviation for security Y. We have calculated the standard deviation for security X. Now we want the standard deviation for security Y. We do the same. We'll be picking the returns of the security, and then we minus the expected return on that particular security which you have calculated here. So we'll be lessing 21.2. 21.2 in each case, as you can see here, we are lessing 21.2. We close the brackets and then we square, then we multiply by the given probability. So you can see what we are doing here. We are picking Y. 15 minus 21.2 into brackets multiplied by 0.3, and then 21 minus 21.2, close the brackets, you square, multiply by 0.2, and then 25 minus 21.2, close the brackets, you square, then you multiply by 0.5. All right, that is what we have just done there. That's what we have just done there. All right. So we have this information here, security Y. Sum of that, you get 18.78. Standard deviation, the square root of that, which is 4.331. We are through that. So number 3, we have answered that. The standard deviation of securities X and Y. Number 4, Robert Mugambe has invested that percent in portfolio X and 70% in portfolio Y. What is the portfolio risk with respect to his investment? All right, in that case, in number 3, we are calculating the risk for each individual portfolio, X and Y. But here, we are saying if you combine both both securities, you invest in both security X and Y, what is the risk if you combine both securities in the proportion of 30% is to 70%. Now, I've the formula that you'll be using to get the portfolio risk is the square root of weight. The weight now, weight of X squared. Because you are saying he has invested 30%, that is the weight. That percent, the remaining is 70%, will be the weight of Y. So we'll be taking the weight of X squared. We have been told Robert Mugambe has invested that percent in portfolio X and 70% in portfolio Y. So weight of X squared means the 30% of X, that is 0.3. That's why we are taking 0.3 squared. Then you multiply by the standard deviation of X squared. The standard deviation we got 2.211. You square, then you plus weight of Y. The weight of Y is 70% or 0.7. So 0.7 squared into brackets, then standard deviation of Y squared, 4.331 squared, then you plus 2. He has combined two portfolios, portfolio X and Y. So 2 multiplied by covariance. We got our covariance is 9.42. This is our covariance, 9.42. So you are taking 2 times covariance of 9.42 times these weights now, 0.3 times 0.7. In other words, the 30% and the 70%, which you write in form of decimals because you invested that percent in X and 70% in Y. So this is just 2 times covariance, which we have calculated, times these that percent and 70%. So if you work out that now, you will get, if you work out that from that particular point, you get something like that. Portfolio risk, the square root of this number gives you 3.69. So that is a portfolio risk. Then expected portfolio return. It will be given by the expected return of each portfolio times the weight. In other words, we got expected return on security X, we got 12.9%, and for Y, we got 21.2%. That is what we started with. That is expected return on security X, 12.9%, and for security Y, 21.2%. So you just need to multiply by the weights. So we'll be taking 12.9% times 0.3 because he had invested that percent in X plus 21.2% times 0.7, and we get 18.71. 18.71. Right, that is that. So the next question is similar. The next question is similar to the one we have done. I don't think whether I should take this one for you, but I think you can just have it as your assignment. The following information relates to returns of two securities under three states of the economy as follows. State of economy: boom, normal, recession. Probability: 0.40, 0.50, 0.10. Return on security X: 18%, 14%, and 12%. Return on security Y: 24%, 22%, 21%. Required expected returns on security X and Y. Number 2, standard deviation of returns on security X and security Y. Number 3, Kalama Chivuva has invested 20% in security X and 80% in security Y. Determine his expected portfolio return. Number 4, calculate covariance of returns of security X and Y. Number 5, determine the portfolio risk as measured by standard deviation. Right. I think I should give you that one as your assignment. I think we have it's a similar question that you have done in terms of the concepts to be applied. I don't think whether it is I don't see whether there is need to do it together with you, because the expected return, you are told expected returns on security X and Y. What are we supposed to do? For expected return for security X, you are taking for the boom 0.4 times 18 plus 0.5 times 14 plus 0.1 times 12, and you get 15.4%. For security Y, the same. The expected return for security Y, you are taking 0.4, that is the probability, times 24 plus 0.5 times 22 plus 0.1 times 21, and you have 22.7%. The standard deviation. Standard deviation, you are taking the return on these securities and you minus the expected return which you have calculated. For example, for X, and then you multiply by the probability. For X is 18 minus 15.4, then you square, you multiply by 0.4 this way, then 14, this 14 here, minus 15.4, this 15.4, you square, then you multiply by 0.5, and then 12, this 12 here, you minus 15.4, you square, multiply by 0.1, and then you sum up these numbers, you get 5.04, and then the square root of 5.04 will give you standard deviation of 2.24. You move to Y. I don't need to show you the Y now. It's the same concept that you have applied here, only that here you are taking these numbers here, these returns here, you minus the expected return, then you square that, and then you multiply by the probability. For example, this one will be 24 minus 22.7, close the brackets, you square, then you multiply by 0.40, you do the rest, you do the same. This is what I'm talking about here, and then you sum them up, then the square root of this number, which is 1.1. The next is expected portfolio return. Expected portfolio return, you've said you'll be picking the expected return and then you multiply by the weight, the proportion. We've been told that Kalama Chivuva, let me take you where I am. We have been told that Kalama Chivuva has invested 20% in security X and 80% in security Y. Determine his expected portfolio return. So be taking for security X 0.2 times 15.4, you close the brackets, plus 0.8 times 22.7, and that will give you the expected portfolio return, So the expected portfolio return will be given this way. For X now, we are taking 15.4. You can just ignore the percentage. 15.4, which is the expected return of security X, times 0.2, that is the weight, and invested 20%. Then you plus 22.7 times 0.8, and invested 80%. And our expected portfolio return is 21%. Lastly, we have also another question here. So we are told Kalama Chivuva has invested 20% in security X and 80% in security Y. Determine his expected portfolio return. So expected portfolio return, we have gotten 21%. We've gotten 21%. Then the next question is calculate covariance of returns of X and Y. Now, was there covariance there? Calculate the covariance. You should be able to do that. Did I take covariance? Now, I may have forgotten to take the covariance. However, okay, I think I have done it. I have not forgotten, but I'm given the formula for portfolio risk that we are going to use in the other step. So we have covariance. We have our covariance here. 18. So we'll be taking we will be taking the returns on the security. We minus the expected return, and then we multiply by, that is that of X and that of Y. For example, 18 minus, we take 18, 14, and 12. That is this 18, 14, and 12. In each case, you will less 15.4. You less 15.4, the expected return. And then once you have done that, you expect something like this, 18 minus 15.4, 14 minus 15.4, that way. Then you multiply by that of Y now, because Y, what we have is 24, 22, and 21. In this case, you are minusing 22.7. You're minusing 22.7 in that case, and then you multiply by the probabilities, the respective probabilities, which were 0.4, 0.5, and 0.10. This one there. And then once you sum up those numbers, you get covariance between securities X and Y is 2.42. Now, if from that now we can have our portfolio risk, and this formula should have appeared afterwards. It's still okay. So we take portfolio risk. We have said the weight of X squared. They invested 20% in portfolio X. 20%, that is what we have been told by that question. Kalama Chivuva has invested 20% in security X and 80% in security Y. Determine his expected portfolio return. So 20% and the other was 80%. So we had to get portfolio risk, the weight of X, 20% squared, multiplied by standard deviation of X, the SD, we got 2.24. 2.24 is the standard deviation of X, 2.24 squared. Then you plus the weight of Y. Weight of Y, they had invested 80% in Y squared. Then you multiply by standard deviation of Y squared, and the standard deviation of Y squared, we got 11. We got 11. The standard deviation of Y, we had gotten 11. We had gotten 11. Then we plus 2, because there are 2. We have invested in 2 portfolio, multiplied by 2, times covariance. Covariance is here, 2.42, times weight of X times weight of Y. That is 0.2 times 0.4. Then the square root of that, and the portfolio risk is 1.88. That is it for that. Now the next I'll give you as your assignment, I'll leave it with you. The forecasted rate of return from investment in securities X and Y over the next 5 years as follows. We have here 2022, 2023, 2024, 2025, 2026. Forecasted returns for security X, 10%, 12%, 8%, 15%, and 10%. Forecasted returns, security Y, 12%, 8%, 13%, and 6% required. The expected rate of return for security X and security Y. Number 2, the standard deviation of securities for, I beg your pardon, let me take it again. The standard, that is number 2, the standard deviation of returns for security X and security Y. Number 3, the coefficient of variation of security X and security Y. Number 4, interpret results in security 1 and security 2 above. So we did some solution here, but I will not show you page 70. Can you work out that? You can do that as your assignment. I'll give you 2 assignments. That is one. So take this one as one of your assignments. So this is your assignment for this lesson. This example here, let it serve as one of your assignment, even though part of it I've done it for you. So you take that one. You take that one as part of your assignment. What is appearing on the screen is your assignment. It's written as an example. Now the other that I want you to take as your assignment is that portion. Is that portion whereby you are told. Now the question starts from here, where we have written using a biro. Tom has bought shares whose percentage returns under various states of nature are given below. Probability 0.5, 0.3, 0.2. Returns for X and Y. For X is 18%, 19%, and 14%. For Y, 21%, 22%, and 18% required. Determine the expected returns, standard deviation, and the coefficient of returns. Okay, I think we have done this one in the illustrations that I've done, but you can take it first, answer the question first, and then you can mark for yourself. Expected returns, I've done it here for you. Standard deviation For X, the standard deviation now this is it for X or it is for the portfolio? I think what has been done here is a standard deviation for the portfolio or the portfolio risk. Now this is portfolio risk. This is not a standard deviation for that particular security. So what has been calculated here is portfolio risk, and then coefficient of variation, then standard deviation of Y, and then standard deviation is there, and then another part. Assume that in the above example there are no probabilities. So how will you calculate the expected returns without probabilities? So you work it out that way. So have that as your assignment, and the rest, I think my focus, I've just done my part. I've shown you two examples. Which we have covered very comprehensively, and I think once we take two more or one more question from this chapter, you will be quite okay with what we are doing. My name is Mr. William, and I request you to subscribe to YouTube, and in case you need my help, my numbers are just down there: 0727871093. This is Fatima Institute Center for CIFA Studies. We are based in Dhaka, so in case you need our assistance, you feel free to visit us. We can also assist you through online classes if you can't make it physically. That is enough for today. Thank you for watching. We meet next lesson. Have a good night.